All right, here we are. Hello, everybody, and welcome. I gotta fix this. There we go. That's fixed now. Haha. Welcome to Heart. It's Friday. It's the 8th of July, and that is a day that we're hanging out here with one Len White and one Christian Sparks. We're going to talk about the joys of tech art and procedural generation and all that fun stuff. Starting up, though, why don't you two introduce yourselves? Len, you can jam out first. Who are you? What's going on?
Hey, Alex. Hey, everybody. My name is Len White. I am a lead technical artist at Heart Machine, and I am part of a two-person tech art team, and we're basically spearheading a lot of the procedural generation and decking of our game Breaker.
And Sparks, who are you?
Hey, I'm Christian Sparks. I'm the other half of the two-person tech art team, focusing primarily on like procedural tech, but occasionally helping with like tools and materials and whatever I can get my hands on.
Even like lumber? Just
even
like
lumber.
Even 2x4s?
Lumberyard.
Yeah, go to the lumberyard and just make tech art out of that.
That's right.
I've heard it's possible if you've got the willpower. All right. Well, thanks for hanging out. We're going to talk about a whole bunch of things, but I guess kind of first up, it might be good to understand. Maybe Len, you could speak to a bit about like what exactly is tech art, or at least what exactly is tech art to you?
Well, every studio tech art can mean a little bit of a different thing. So speaking just of Heart Machine, I was technical artist on Solar Ash, our previous title, and now on Breaker. And it basically runs the gamut of doing art that is too weird or technically difficult for a kind of typically trained environment artist or animation artist. So when there's a need for something that maybe borders on visual effects but isn't quite visual effects, sometimes it includes things like destruction, where you have objects environment artists have created and you want to like smash them apart and have them fracture when you hit them. I did a bunch of that stuff at a previous job. But then it can also go into tools and systems. So when an artist is doing something over and over again and it's getting super boring, tech artists typically have a handle on all of the scripting sides of the various authoring tools like Maya and Substance, Blender and other things, and Unreal. And so we can often are called on to sort of automate things that are super boring or tedious that could be just done like formulaically, and give those tools to the artists, even making kind of front end panels, which you're going to see some of that later with the procedural stuff we've done. And then getting into systems. So systems that don't fall quite into engineering because they need to be closer to the art. And they're not going to be using typical engineering tools for at least all of their work. So not C++. So kind of like engineering light to some degree, but often in a way that needs to communicate very closely with the art pipeline. And I think that is what like Hyperdeck and our procedural gen system that we're developing for Breaker kind of falls into that category. I think tech art can kind of be all these things. Sometimes at certain studios, it's more one. And sometimes at a studio like Heart Machine, because we're not a big studio, it very, very often is everything. Like we are touching so many aspects from materials, as Christian mentioned, from materials to modeling to prototyping to doing procedural work, systems, tools, all that.
Yeah, it's a whole new world of like a wide array of things when you say tech art, for sure. And I know I've over the years of working, with other folks on that front, and then Len, when you joined up for Solar, learned a whole lot about what it can mean to dig into the technical art side of things, where it's this kind of bridge between a lot of different disciplines. It's like this glue that holds things together. It's like a way to translate different elements from art to engineering. And so, that can mean so many different things. Christian Sparks, I'm going to kick it to you here. Could you tell us a little bit about yourself and how you got into games and how you ended up here at Heart Machine?
Sure. I've always been super into just playing games my entire life, like a ton of people. I got my first computer when I was 20 and started playing around with modded versions of like Bethesda games like Skyrim and Fallout and so like Minecraft, and that led me down like getting interested in like exercising game design ideas that I had that I wanted to try out. And so a couple friends recommended a few different tool sets to try out, and I tried a few different things and landed nearly 8 years ago with UE4, and just started like wanting to make this, that, and the other game and needing the pieces to do that, and rather than like buying the pieces outright through marketplace assets initially, or like trying to bring other people in because I didn't want to subject people to my bizarre late night schedule, I would just dig into trying to learn how to do that stuff on my own, and that just led to like 7 or 8 years of exploring different things and trying things out and sharing stuff, and then getting to work as a result with like people that I really admired on different side projects and contract work. And then last year around this time, I think actually a friend was like super encouraging me to apply to a few different places because I really wanted to transition into games full time. So that's where I applied to Heart Machine and got a conversation started with Alex and a couple other people, and here I am.
Here you are. And Len, what about you? How did you get your start in games? Really, like what led you to wanting to actually make games and actually land in a gig in it?
Well, my first passion actually when I was a kid in the 80s was I wanted to make games, and so it was very hard to learn how to do it. There weren't any game engines, so you kind of did it from the ground up in assembly language. And at one point I got into Modula 2, which was a kind of successor to Pascal, which eventually morphed into C#, I think. Same guy who wrote C# apparently wrote Modula 2. So I remember as a kid, at some point, I decided video games were the coolest thing in the universe, and that the only thing anybody with a sane mind would want to do with their life is make video games. I remember having that like absolute passion. And so I actually was making video games for a while. Then I went to college for computer science, but that was so discouraging. It was not at all fun. It wasn't about making games. It was about bubble sorting lists of numbers and those sorts of kind of homework problems. And I was just like, this is wrong. So I sort of bailed from that and ended up going into physics. And that was because my dad was a physicist, a working physicist. And so I got a degree in physics. Then I got another degree in physics, which I really should have stayed in games. That would have been smart. But I didn't. And then when I got out of college, I kind of didn't want to do physics, and I went back to my love of games. But at that point, I kind of was now seeing that my love of computer graphics was really sort of a lot of what was behind my love of games. And I scored a dream job at Rhythm and Hue Studios working in film effects. And they basically taught me so much. And I worked in film effects for 10 years. And I worked on commercials and movies and stuff. And then I took a break from that to move overseas. And then when I came back, I was like, all right, I should go and do what I always wanted to do since I was a kid and work in games. And so I basically started applying for jobs and got a job at Neversoft, which turned into Infinity Ward, working on Call of Duty. And so I worked on Call of Duty for like 4 years at Infinity Ward. And then that was basically the beginning of my games career.
Which Call of Duty was the first? Did you end up working on?
I worked on the ones nobody likes, unfortunately.
1 through 3.
No. I mean, Call of Duty Ghosts was my first title. I won't say nobody liked them. They sold millions of copies. So
sure.
To say nobody liked them, but when you work at Call of Duty, if you're not like making $1 billion on your title, it's considered a failure, from what I could tell. The standards are kind of insane. So Call of Duty Ghosts, and then the one title I worked on from beginning to end, it was Call of Duty Infinite Warfare.
Hmm.
And then after Infinite Warfare, I left Call of Duty forever.
Yeah. I liked Infinite Warfare. I liked Advanced Warfare. I know a lot of folks didn't, but I mean, millions of people did. So, okay.
Thank you.
Well, let's talk about current work and tech art and what we're doing on this project. I have some videos to share here. I'm going to swap my screen out, and we're going to see something popped up here. So I believe that, let's see here. Yeah, we're going to talk about Hyperdeck, I think. Is that correct? And this is a you video, right? Christian Sparks, you're going to speak to this one here about how this all is starting to work when we have our cluster tests.
Yeah, so the initial tests were just like building out over existing terrain setups where we had these procedural terrain layouts, and we wanted to be able to sort of like set deck or decorate the maps the way that an artist would without having to leverage so much artist time and effort. So it was, procedural systems are perfect for that. The interesting challenge that we came across, I think, was kind of trying to pipe in some artistic intentionality into these procedural setups. I know early on it was just like, hey, we can place these things in certain ways and have them avoid things or only spawn in certain orientations or surfaces.
Yep.
But over time, it became like a clear desire that we wanted to have, much more artistic intention behind it, so that it looked as close to like someone had hand decked it as possible.
So just to, I'll pull it back a bit and talk about kind of our approach here and like process and how we ended up in the space that we're at with Breaker specifically. Procedural generation in games has been a thing for ever and ever, but it gets more and more complicated and less and less recognizable as the algorithms and everything else gets smarter and technology catches up. And so I'd be willing to bet that, a lot of modern games that everyone plays has a ton of procedural generation in there in some fashion or another, and people just don't realize it, especially with big open worlds. Because the thing is, trying to deck big spaces takes a lot of time and effort for artists, for designers, for all manner of folks to like get that location to look good and then play good and all that other stuff that comes along with it. And so for our game, for Breaker, we have these really big levels. It's a lot of exterior stuff, but we also have some structures and interior things as well. And ultimately, we have a smaller team. We're not a big AAA studio. We don't have, like Guerrilla Games has like a whole dedicated array of tech artists building things out, and like dozens of artists across the globe, or at least in their studio, putting together things. We have, a handful of folks on the art crew, creating assets and decking things themselves. And so if we, as a smaller company, smaller team, want to make something really big, then it's to our advantage to leverage math in order to help fill in the gaps there, to let the machine do a lot of that work. And really what procedural generation is us giving direction to the computer at the end of the day. It's us, giving instructions so that the math is spitting out numbers and everything else in a way that is pleasing, that is going to hit our marks for gameplay and otherwise. And so we've spent a large amount of time over the past, at least a year now. We're like really digging in on these fronts very seriously. And then over the past 6+ months, getting real heavy with some of these other systems that you all have lovingly tagged with Hyper at the start of them for our tool sets. Is there more that you'd like to say about this video, or can I jump to our custom scatter part 2?
Yeah, we can probably jump to custom scatter part 2. That initial video was just, proving that we can lay things out and have them aligned to the terrain. Custom Scatter Part 2 starts to showcase this concept that we had of when we're placing these objects, they would serve as sort of a route. And then we would have supplementary or like secondary or tertiary pieces that would spawn rather than just like at random positions. They would spawn starting off at the same position as their root parent and then position like offsetting themselves from there. And so that would allow us to do certain visual layouts where there was like a clear I guess language and natural layout of and relationship of different assets together. And that sort of became like a really core foundation piece that still lives today in kind of another like secondary system that works hand in hand with the proc gen that we'll talk about later. But yeah, I think here, we have some like initial layouts where we can do, or is this number 1 or number 2 that's on screen right now? Sorry.
It's looping back. Just fast forward. There we go.
Yeah, so we can see like the custom scatter stuff, and then we had like, relational distances between like targeted classes, only spawning on certain classes. So, you could only spawn on certain types of surfaces, avoiding those surfaces by different distances. And so those are the kind of like rules and constraints that we were feeding into this system and sort of balancing those things out against like gameplay desires and environment art desires to get the target result. This initial implementation relied really heavily on tracing across the board. So we're taking like a given point on if you imagine, the terrain is a flat plane, we're tracing from above the terrain down to find, the height and the slope of the given spot on the terrain.
Yeah.
And so that, while, super effective and really easy to stand up, has a lot of long-term costs and instability with like replication in particular. And so
I'm gonna stop you there for a moment. So, when we talk about replication, we're talking about multiplayer basically, right? We're talking about like, not only does this stuff need to work when we're playing the game in single player, but because our game is multiplayer, it needs to work across other players' situations. They have a server, blah, 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 not to get too technical about it, even though we were talking about technical art. There's still, some awareness here on like, it's not the same thing to do things just in single player as it is in multiplayer. There always has to be awareness of how things end up working on the multiplayer side. Otherwise, you're going to have some real broken things happening when you jump into multiplayer together. Okay, I'm going to jump into this fun zone GIF that we have of the maps. Let's talk about our maps and our zones for a moment.
Sure. So a big part of our, I think, design goals is to have very clearly differentiated zones in each map that are represented by like differences in terrain features and props and enemies and all sorts of different things. And so we needed a way to identify that really, efficiently. Len has some really great tech on the landscape side that provides those sort of zone IDs in those chunks of the terrain. And then there's kind of a core piece of tech that one of our engineers, Peter Hastings, put together that allows us to kind of read essentially what is like a zone texture that scales over the entire terrain and read it really efficiently so we can tell what zone each point on the terrain is in. And apply specific assets and material effects and all sorts of different things into the terrain. And so what you're seeing like in the GIF there is with this like Google looking thing is just
it's Google Chrome.
Yeah, it's Google Chrome the game.
That's what we're making, everybody. The secret's out. Google hired us to make their new browser, and it's in Unreal.
And that's why we have so much money.
But yeah, that's each one of those colors just represents a different zone. Now we have this kind of like screen effect where you can see the actual digit of the zone. That's not really. I don't think I provided an image for that, but regardless, that was how we identified our zones in our documentation, was through these kind of color IDs, and so we can target specific zones and put different assets in different zones.
I love different assets in different zones.
That's right.
I think it makes our worlds very very engaging. Like as we build out these landscapes and as we slice them up, those distinct zones become more and more valuable ultimately when it comes to how a player can navigate the space better. Like it gives you a quick view of like, where am I? What part of the world am I in? Because these spaces get rather large. And so being able to have those distinct zones with particular components in them, meshes, enemies, or whatever else that we want to actually place in there, all through math, all procedurally, that ends up really helping us to, again, create these distinct areas that really give you a sense of place and directionality that otherwise, if it all looked the same, it'd be kind of boring and kind of difficult to tell where the heck you are.
Can I add, Alex, that I think the zones are one of the critical pieces in my mind that are about tricking the player into thinking that our levels are completely hand manicured experiences, whereas what we're trying to do is create an impression of an infinite number of different cool levels that you can play. Mm-hmm. And so to do that, you can just randomize everything and you get an infinite number of levels. But then you get into the situation that it just doesn't feel like a real game. It feels like randomized levels. And maybe that's okay, but what we're shooting for is something that makes you feel like they were hand created, but we can have thousands, tens of thousands of them for unique play experiences. And the zones are important for navigation, but I think of them also as very important for breaking up the proceduralism or the perceived proceduralism, if you will. Mm-hmm. I just wanted to mention that because I think the art team does a great job of also tackling each zone and making each one feel very, very hand tailored, as if an artist did all the work, to create that level. But that's not the case.
Yeah, I mean, they do a lot of work on the art side to build out all the different assets and even do what we're calling target levels. And so what that gives us is a target to look at and say, like, how do we hit that, with math? How do we hit that with our systems that we've built out? And Len, absolutely what you're saying, like on the zone side, there's a lot of different reasons why it's important for our levels, our maps, and everything we do, including, artistically and otherwise, navigation, gameplay, all sorts of reasons why, like breaking things down into this more granular chunking system ends up making these spaces really feel, as you had said, more handcrafted, because that is ultimately our goal here is to get as close as possible to fooling ourselves, the illusion of like this was totally crafted by a person and you cannot tell the difference. We'll do as best we can to make that true. All right, I'm going to jump into, was there anything else on these gifts, or shall I jump into, let's jump into number 7 here. We're moving along briskly. So this is a fun one. Hyperdeck is a tool, and Hyperfab is like a part of that tool. Is that correct?
Yep, it's kind of a sister program or tool to Hyperdeck. The two work in tandem. Hyperdeck is what places these pieces, and Hyperfabs are sort of a play on prefabs, but with some additional functionality. So,
what is a prefab?
So a prefab typically is like a collection of assets arranged in an artistically desired way that can be redeployed multiple times. So it's really handy to have, but we took it a step further and sort of applied the terrain evaluation stuff that we had and the relational evaluation stuff and added some additional features to the prefabs, which is what you're seeing here, where the different pieces can kind of all still align to the terrain rather than retaining their original flat composition. And so it makes them really highly adaptable and really pleasing, I think, to look at. And it allows our artists to go in and create these sort of like perfect corner pieces that achieve that artistic intentionality, literally. Yeah, here's another really great piece. And this scales up to like ridiculous proportions. Like this is like an entire city block that is made of this composition that was put together by Wolf and Enviro. Shout out the Enviro team. And yeah, you can literally move this around the terrain, and all of the components will like intelligently adapt to the terrain and move themselves around. It's really cool.
Yeah.
In case anybody's excited, unfortunately, these do not slide around the terrain while you're playing the game.
Yeah.
Looking at this, it would be very cool. But
we're not making Inception, unfortunately. But yeah, it is very cool to see how adaptable it is, because this isn't standard out of the box behavior. Like you all have created these things to function this way, to really pay attention to the landscapes that they're on, and make sure that they're doing all the math that's right to end up orienting in the correct way. Because I mean, you can even see some of these shapes dancing around on little street pieces and stuff in this GIF. But, you know, there's a lot going on under the hood to make just what seems like a relatively simple idea work at such a large scale, you know, across the board. And this is part of how we end up making our levels feel more handcrafted, is by literally crafting pieces of them, you know. And so you kind of mix and match those elements of like pure proceduralism with handcrafted elements, and fuse them together to get something that overall like gives us the variety and breadth, but also what is valuable to us, which is, you know, a very very high bar of quality for you know, a look and composition ultimately, as well as like gameplay and how it actually feels to play in these spaces. So we talked a bit about our hyperfabs and fun things like that. Len, why don't we talk about terrain generation and kind of our journey there? I think we have we have this fun screenshot up.
Yeah, sure. So yeah, terrain is, the way we treat terrain in Breaker is as pre-generated meshes that are imported into Unreal, and at gameplay time, the system selects between however many pieces of terrain we have, which we call variants. And the target right now is to have about 100 of these, but that could change. And then on top of those 100 variants, we're going to deck or hyperdeck all of those awesome hyperfabs and other assets that Christian was just talking about. And through the combination, get like what we're seeking, which is this apparent never played the same level twice, wow, this feels fresh every time kind of experience. So the terrain is basically kind of the foundation on which everything sits. That first image, the green background, was initial work done by Peter Hastings. He kind of was the lead on this at first until I took it over, and that shows some of the kind of foundational work he had done by doing it very algorithmically. And this was very much pure math. He was literally generating the geometry with mathematical formulae and then getting some really cool results, much of which is still the foundation of what we're doing now. But then we took it to Houdini, because we realized that we kind of were going to kind of stretch the limits of doing it purely with math, given the amount of iteration and experimentation that we knew we wanted to do. So Houdini seemed like a good fit. It was great because we could literally take his formulae and translate them into nodes in Houdini at first and get kind of the same results. And then we found that we could basically start doing a chain of processing after the math. And this is kind of showing the Houdini network that you see on the right, taking what starts as a simple circle, fracturing it, and basically taking, getting a footprint of an island, fracturing it into sub-islands. Each sub-island then uses height field noise to kind of create interesting shapes. Again, each variant will have completely different looks to these islands and sub-islands, because all of these noise fields that I'm using here are all randomized. So as it proceeds, it fractures into sub-islands. Those sub-islands then get kind of their final shape, and we then calculate the coastline and use signed distance fields to generate the kind of beach to land transition. We create cliffs along those beaches in some places and some places not. And then we start scattering specific shapes that are specific for gameplay. So you'd see those little kind of perturbations coming up. And then at this stage, the red border is basically forming the boundary wall. So after we have the kind of primary island play space defined, then the final nodes in the chain are building up these boundary walls to a particular height. And we have several stages which all kind of tweak this formula. In some cases, they break this formula and use different subchains to do different kinds of things. But that's basically kind of the approach. And then this terrain, which is about a kilometer wide, kilometer square. Of course, it's more circular, bizarro, blobbo shape inside of a kilometer box. That terrain gets split up into tiles so that we can use level of detail across different tiles and get performance benefits. And then that comes into Unreal and forms the basis upon which all the scattering of all the other assets happens. In addition to what you're seeing here, a lot of what Houdini generates, one of the things Houdini is really good at is doing geometric analysis offline. So we are tagging all the sub-islands for which zones they're in, and Houdini also generates textures that then are imported into Unreal for all the variants, and that forms the basis of the zone differentiation that we were seeing in the Google Chrome image that we saw earlier. And this doesn't really show off the cool landscape terrain or material that Environment has developed, but it is showing essentially what the results look like, at least in a basic way, if you just take that mesh and put it into Unreal and apply a kind of basic material to it. And then we, of course, have the water plane and sky, and it all starts to come together. So this is sort of the naked terrain.
Well, it's also recognizing elevation in it, right? You know, like we can see that we have some of the beach near the shore. You know, it seems like it, you know, for folks aren't aware, it seems like it's recognizing, you know, what the slope angle is of terrain as well to give it the certain textures and everything. And then, of course, it's painting on stuff for the tops of like our grass and all that stuff too, right?
Yeah, we have a lot of, I guess you could call them control maps and masks that are being generated in Houdini also. So along with the mesh, we have not only JSON formatted sort of numerical data that kind of tags zones for their surface area so we can play games with density, but also the control maps for where cliffs rise up from flat surfaces. So we can use those to control where certain assets will form if we only want things forming, say, at the base of cliffs. And then we have this idea of cave systems, which I think there's a lot. Yeah, this is the idea of the zone. So obviously that terrain doesn't match our current kind of terrain, but the idea is still there. Yeah, so there's a bunch of data all flowing out along with that mesh that comes into Unreal to give Hyperdeck the necessary information to do its job.
Yeah, we still have a ways to go as we dig into this stuff, but we've come quite a long way from even just those early days of using voxels, like when Peter and I were working on it before Len and Christian, you had kind of jumped over onto this. We were, you know, we had experimented with a lot of different ways to build out our levels. You know, we'd started with a more traditional stitched together style that a lot of, you know, roguelikes and other games in that sort kind of do, but it wasn't really hitting the marks that I wanted to hit with it, and so we ended up getting more complex and digging into voxels, which was fun and a good experiment, and one of the images that we showed here, one of the early instances. And then, right, as Len came aboard, as he was saying, like those limitations became more clear of like what this could do, and hey, Houdini would be a good tool to jump into and start to build this out. And so now, you know, that kind of leap from the early days to right now, end of June, early July, there's been such substantial gains. I do wish we had like a screenshot, but maybe I'll pull one up. of kind of one of our more fully decked spaces these days, but it's taken a pretty big jump from what we'd had just 6 months ago, at the beginning of the year to now, and that's an immense amount of progress ultimately. I guess I would ask both to you and you, Len, and Christian, like seeing the progress and having been in the trenches there, like the people really digging in with environment art and otherwise and building out these tools, like and also this kind of being the first time around on a lot of these things, experimenting and just a lot of trial and error. I mean, how challenging has the experience been for you both to get from where we were to where we're at now?
Christian, you can start.
Sure. I think a big part of the challenge for me was transitioning from this like entirely reactive, runtime evaluating procedural setup to moving a lot of these tools into this sort of offline format and learning the methods to do that. And then also like really pushing the boundaries of what I understood about and what I had employed previously, like just in side projects and stuff, about procedural generation. And again, pushing on that artistic intentionality in new and creative ways. So it's definitely been challenging, but I think you really highlighted it. Like the past couple months have shown some massive improvements, and that momentum seems to be keeping up. And so I'm really excited to see kind of what we turn around even in the next few months.
Yeah,
on from there.
I mean, what we're showing here is a lot of early days stuff. All these different videos and GIFs and whatnot. The kind of jump from where we were just the beginning of the year to where we are now is super exciting, and to see that progress. And there's definitely a lot of ups and downs. They're like, it's a risk, of whether this is really going to work or not. And there were some early proof of concepts about like what we could do. The voxelization stuff with Peter and I was one proof of concept, and then pulling it into Houdini with you, Len, was kind of another proof of concept that this would work. We delivered our vertical slice internally, and now at this juncture, and kind of the reason why we're having this conversation now is because we've hit a mark that it feels like we've kind of gained our footing and have a lot more confidence overall in the systems that you all built, and the way that they're interacting together and able to like capture the spirit of what we're trying to hit, rather than just being like, oh, this is a procedural level. It's like, no, this is hard to tell at this point in a lot of pockets. Like, we still got ways to go before we hit our early access goals, but there's definitely some very convincing points, more so than not, that really tricky into thinking. It's that illusion of like, oh, right, that all these things are finally working together in a way that is really hitting its stride overall. So as far as procedural systems go, talking about kind of the challenge of it, I wonder also, kind of a wild question for you all is like, if you had an unlimited reign here, like how far do you think you could push it? Looking at what you've been able to do thus far, both of you, the royal you, the everybody you, the plural you, not even just like, over the course of now to early access, but if you had like 5 years and this was your passion project, like how far do you think you would be able to push a procedural system like this? How convincing do you think you'd be able to get it, to mimic what, artists can do?
Len, do you want to go first?
Yeah, I suppose. Well, there's a lot of things that we had to do because we just had limited time, like research and development time, because you cannot look up, an Unreal Marketplace asset that does what we needed to do. Like we had to roll a lot of this, and one of the things I've learned about studios, when you're working just on your own in Unreal, it's one thing, but when you're working at a studio and suddenly there's multiple people that all kind of need to touch or understand or tap into a system,
yeah,
it opens up the system. It forces an opening up of the system so much that you can't use a lot of like canned solutions or pre-built solutions.
No.
And that's why engineers typically, if you don't have the source code, they're not going to touch it, because they know that in a real development environment, you need to touch the source code. So we ultimately build this up from the lowest levels so that we could do that. And I think we have limited time. We had limited time to do what we're trying to do now.
Yeah.
If I had an infinite amount of time, I'd push more stuff into Unreal, which would require probably a huge amount of Unreal engineering support.
Yeah.
But density is one of them. Like, one of the things that saddens me right now is we're not getting the density of, say, grass and foliage that we need or that I would like.
Mm-hmm.
And there's a whole technology that I'm thinking maybe we could even get it done in our lifetimes on this game. That will allow us to tap into the highest density foliage we could ever need. But it'll take some resources. So 5 years for sure. Yeah, and it's complicated. And also the idea of like building these terrains out in Houdini, I'm loving working in Houdini, but the idea of exporting tons of meshes and bringing those over to Unreal, if I had an infinite amount of time, I would love to explore building up an entire tool set to do that kind of thing in Unreal at runtime. Obviously, there's the Houdini plugin in Unreal, but that is an offline tool. It can't be used to have things be generated at runtime. But what would that look like? That would be an interesting project.
Yeah. So we've taken this hybrid approach, where we're generating a lot at runtime, but we've kind of established these baseline chunks of landscape for ourselves. And there's a lot of things that can or cannot be true about them, but that's what we're talking about when we say like online or offline. It's like in procedural generation, how much of that math is being done like when you press load, like when you press play in the editor or in an actual game, in a build. And so some games go full procedural, like 100%, every cube in it is built up from the ground up. That's something like Minecraft, for example, in 3D, or plenty of 2D games that do it, tile by tile. But for us, we're kind of hybridizing this because it is a 3D game, because there is a lot of complexity here, because we don't have 55 years to make all these things and build all these like very robust tools to basically replicate what Houdini does in Unreal on the fly. As Len is saying, that takes a lot of heavy lifting ultimately, and so we're mixing and matching and still getting this result where we get essentially very similar results to that infinite variety, of course, with some limitations, and getting as close to that as possible, and still getting immense value and variety out of the systems we've, put together. So I do think we've approached it in a relatively clever way to give us, what we need out of it, and that extensibility and replayability, where it's like, because of the layering of everything, you shouldn't really be noticing, these many, many different variations that you're getting. It should be pretty fresh and new no matter how long you're playing it. Okay, well, it's 3:43, and I figured it's time to maybe ask some questions, or pick some questions to be asked of us here. So let me see here. What do we got? Doc McButt. That's a good name. For Len and Christian. What's been the most fun but challenging part of tech art for you both? And that's just a general question, it seems like, in overall in your careers.
I think for me in tech art, actually is really recently and does pertain to work here, is learning to leverage Python in UE4. I had some like very brief experience with Python in previous jobs, but it was related to like financial programming, and that's super boring. And with this, it kind of opens up this like really huge possibility space of tool sets and automation that were previously totally out of bounds for me. And so I had to learn it pretty quickly, but I'd like to think that I can kind of navigate through it quickly enough and efficiently enough now that I can turn around some pretty cool stuff. And Len's been a super awesome teacher on that front, and I'm very grateful that he knew so much about Python already.
Yeah, that's great. Len, what about you? I mean, could be here, could be your career. Like, what's been a very fun but challenging part of your tech art experience?
Wow. Yeah, thinking back through all my old jobs, which I forget about the minute I quit. I think it's probably the first job I used Unreal at was only like a few years ago, and Unreal has a lot to it. Unreal is a complicated beast even before you start doing work in C++. So, you have the material network, which can be a lot of fun, but when you need very specific results, it can be pretty challenging sometimes to balance good materials with performance too. So I would say probably one of the biggest challenges is when I was first asked to move from being a tech artist in, say, the Call of Duty engine to going into Unreal and having and as a tech artist, you kind of want to know everything and you want to know it a little bit better than everybody else, because all the environment artists, they can make art better than you, but you're supposed to know the tools better than them. And when you're suddenly presented with all of Unreal and you're suddenly demanding upon yourself to be better than everyone else at Unreal, it didn't really work out overnight for me. So that was a pretty big challenge, and it's still ongoing. I'm still learning nooks and crannies of Unreal that I'm like, why didn't I learn this 10 years ago?
I mean, it is a beast, and I think the fact that that you have source available to further do whatever you really want to do to it, to modify it, ends up making it that extensibility just makes it kind of wild with the possibilities that you can put into it. Even with Solar Ash, we did a lot of modifications to the engine. Otherwise, I mean, one of the key things that we had, which was bananas, was like, oh yeah, let's forget about what like up orientation is in it. We that's like a core part of the engine and how it works. And it's like, screw it. Let's just do something where we can orient the player in any number of directions, and the skybox and all these other weird things that we ended up trying out that, Unreal allows you to do, and kind of tech art and other engineering ended up helping to really push on those things to make magic come true. So, all right, I'll jump to Dan asks, do either of you have any good resources for learning tech art? Because they feel like the field isn't discussed as much as some other game dev jobs.
Christian, you have some good resources.
It's definitely, I think it's talked about more frequently now. There was like a really big push for tech artists to like acquire tech artists, because it's such like a far-reaching and like varied field to work in. I think I can't point to any specific resources like off the top of my head. I have like kind of this massive library of people that I follow on Twitter in particular that are constantly posting like side projects that they're working and resources that they use. Really kind of immersing yourself in the content that is out there, in the form of, again, those social platforms, blog posts, YouTube videos, and just trying to live in it as much as you can. I think if I were like to go back and try and tell myself what I should do when I was starting out, was just like pick the things that you think are interesting, that are like potentially technically involved, and try and recreate them, and try and figure out how they work, make a mess and break them so that you can figure out how to clean them up and really get to know these kind of core concepts, and before you know it, you will be doing all sorts of crazy stuff.
It is. Yeah, there's a lot of wild stuff.
I would echo that. Like it is weird how few resources there are. Like, I don't even know how many, if there are too many tech art like tracks at like the current schools that are out there. I don't think there's many. It's a funny field, and I guess I would agree with Christian. It's like, if you find yourself wanting to look under the hood of everything, and understand it at a deeper level at the cost of not being nearly as good an artist at these tools as maybe the other artists in the room, then you might be a natural tech artist. And probably the best course of action is to find people that you admire, that'll talk to you, and more important than that is, start working on projects and try to do weird stuff. Try to break things and then understand why they got broken and then rewire them so that the head's on backwards and that the arms are the legs and now it walks like it, I think you know what I mean. Just like try to like reconstruct things in odd ways that challenge your understanding of things.
Yeah, good advice. TD Pod asks, when it comes to story, plot, characters, and world building, writing is one thing, implementation of all of that, and the game design is another. How does Heart Machine navigate that, especially when a story element puts hard demands on the mechanical or design side? Gosh, I mean, world building is a big question, but I'll just say, I'll start from like kind of the biggest part of it. World building takes a lot of background work that has almost nothing to do with the world that you're building an engine at times. There's a lot of kind of thinking about what the logistics of this place are and how it operates, and like, depending on what type of intrigue and interest you're trying to dive into, there's all manner of sectors that you can investigate, from like the politics of the world to just the landscapes and the geography and the types of elements that it has and whatever else it is. But the more of that you do, of that world building in the background, before you even really are doing a lot of like game designs or even level layouts or what have you, the kind of easier it becomes, or not easier, but like more straightforward some of these answers can be. And it's been true of, all of our games thus far, from my view, of like, from Drifter to Solar to now Breaker and beyond. Answers will come quicker and easier when you have a lot of that work done previously, when you have a good idea of what your world even is. And again, like, how you define your world is kind of up to what you want to be doing. And so that also extends into the game design. As an example, when we're talking about weaponry and Breaker, we have a whole host of different melee weapons now that you can use as the player character, and it's great and it's fun. But we also have to ask ourselves, like, where did some of these come from? And stylistically, what are we tapping into with just like the design of this blade? And because we have an established world, that was put into play, way back when with Drifter, and even earlier when I was noodling around with this stuff, it's simpler to say like, this came from this region of the world, and maybe they have this type of design aesthetic. And those types of things are really nice to have in discussions in a group and say, oh yes, we should shape it differently because this culture wouldn't do this, or because this culture really emphasizes this part of this thing, or this region had this type of material and therefore it would be made of this instead of that. And so like the shininess, the reflectivity of this particular blade wouldn't be the same as this other one that may be made of like some dark metal or whatever it may be. So there are elements like that just doing that background work, doing that homework goes a long way towards helping bridge those gaps and answer those questions in those design discussions, in those art discussions, and more. So and it influences the mechanical design as well, because you start to think about like, would this world have jump pads? That's a thing that sometimes worlds have jump pads. Like Halo has jump pads that like shoot you off, and like something that we always try to do, something that I think about a lot when we're making our games, is in-game justification. So if there is an object in our world, if there is an item in our world, it should be able to justify itself believably within the rules that we've established for that world. And sometimes those rules will come naturally as you're building ideas out and building designs out. But oftentimes those rules will start to manifest as you're conceiving of this world in the background. So that background work becomes key in pretty much everything it manifests. It has its hooks and everything, and really helps to like push along, because like, in Hyperlight, I don't think we'd ever have a jump pad like that. Why would we? Why would that be out here? But warp pads, sure, people would put those down all over the place. And so that's the type of thing where it can accomplish the same thing but as an in-world and kind of not just in-game justification for itself, to make the whole thing feel more holistically conceived of, because it is. And that just makes it easier to kind of lose yourself in the game itself. All right, I'll jump to another question. Wolf asks, tech art is an interesting broad title in a lot of ways. How would you both describe what it means to be a tech artist to you? Yeah, I guess that's more specific than, like, you know, Len and Christian, what does it mean to you to be a tech artist, really?
Do you want to go first, Len?
Nah, if you got something to say it.
I don't know. To me, it's getting to kind of be this sort of conduit between a bunch of different departments, and in turn getting to work with a ton of really awesome people. Basically everything that we're doing kind of has us with our hands in a bunch of different pots, and so, you know, interfacing between, you know, environment art and engineering, or you know, engineering and character art. We have to have these conversations with these people to figure out what sorts of challenges we're having and how to solve them, and to get to make those solutions, and then like see what they're able to do with those solutions is like the most fulfilling thing ever. It's super awesome. So yeah, getting to, you know, not just be kind of boxed in a corner, basically.
Yeah, I would say for me too, there's part of it that kind of going to the under the hoodness of things. If you're kind of a person who is looking at the art, but then it's your responsibility to look under the hood of the art. That involves getting into performance. Some of the probably less sexy, fun parts of tech art, but you know, there's lots of ways in Unreal to ruin your performance, and it's just too crazy to assume that engineers will catch that. So it often falls on tech art, because we are typically much closer to the artist. We want to be, we like to be, and so we can advise on those issues, and hopefully, though it's not always avoidable, avoid the dreaded engineer coming down and saying, you can't do this, you're breaking the game with your 70 million, you know, vertex tree, or whatever might have been the problem case. So that's just part of it. But yeah, unfortunately, tech art is it's a wide-ranging area that, again, depending on the needs of the studio, can vary between being very much a strict tools person, as I was at other jobs, to building procedural character systems, to doing some kind of stuff with animation that's not very easy to do for riggers or animators, to what we're doing here with building procedural systems along with engineering and the art department. Kind of really hard to put your finger on, unfortunately, for me anyways.
All right, so let's see. Perfectly Mediocre asks, what are your third favorite dinosaurs?
I don't even have an answer for this.
My third favorite? I prepared a first favorite, and then I did not think of second or third. Pterodactyl, I guess.
Sure.
Third favorite? What? That should be like at least one or two.
Do you have an answer, Len?
I'm gonna say Velociraptor, because they're way too hyped up by modern major film franchises.
It's true.
So drop down.
It's very true. So Kep asks, what's the hardest kind of terrain? Cliffs, caves, etc. you've tried to generate. Which one did you... what's the hardest one that we've done so far on the terrain side? What's been the hardest challenge there?
Interesting. Yeah, thanks for asking, Kep. I remember you from early on. Yeah, our terrain's interesting because our terrain is, I think of it more of as a continuum of moving from kind of one sort of topology to another. Our cliffs are certainly a problem because the way that I'm doing things in Houdini right now, I'm using height fields for a lot of the cliffs, which, just to make sure my Houdini life isn't super slow, I cannot keep the resolution quite as high as I want for most of the pipeline. And we haven't actually gotten to the point where our networks are done and I can just say, okay, go for 2 hours on the highest possible resolution. So right now I would say our cliffs are a bit on the soft edge side, which is something I plan to fix. Caves, we're getting into caves, and caves are cool. They are a little expensive too, in the sense that all the geometry is voxelized in order to carve the caves out of the surfaces. It could be done in different ways, but this is the way I'm doing it now, and it's super flexible in its own way. So I would say caves cost a little because everything gets voxelized in Houdini. Then I build these cave tubes and caverns, and then I subtract those in the voxel or volume space from the original mesh, and so then I can get these natural kind of funneling into other geometries that you can go down and you automatically get some nice collision. That isn't too bad, too expensive. So I'd say that's kind of been a win, and I'm excited about playing with that moving forward because caves are cool.
Caves are pretty cool. I'm excited for those too. All right, well, we're hitting our 4 o'clock here. We're coming up on our time. I know there are other questions, but we should call it at a reasonable time. We started it on time. We should end it on time. Len, Christian, is there anything else that you want to speak to here briefly before we all kind of peace out on this stream? Len, I'll start with you. Any kind of like words of advice or things you want to call out or stuff you feel like you didn't get to speak too much in this session?
I don't know. I would say we're posting that blog entry, right? I guess I need to talk more about that. But I've written a bunch more detailed explanation of that very rapid terrain video. If there's any Houdini peeps out there that are kind of interested in what I'm doing or why, I may not have good answers because Houdini is like a puzzle box that you're always trying to solve in different ways. I also would say the world desperately needs more tech artists right now. So if any of you are watching this because you're like, oh, tech art, I've always wondered about that, and you kind of heard us speak and about what we do and what we're excited about, and it might be something you'd be excited about, I highly encourage you to consider a route in tech art because the number of job offers I get a week is ridiculous, and I need you to take those jobs because I'm not going anywhere. Lots of jobs for tech artists right now.
There's a wealth. Please, yeah.
Join our ranks.
Yeah.
We will help you.
I'll underscore that and say that tech art also includes, technical animation to some extent, like by virtue of being tech and art. And so if you're interested in character work, you can also be a technical artist with a character art pipeline with animation or otherwise with rigging and all that fun stuff. So, tech art means so many different things, and it depends on the person and, like Len was saying, the needs of the studio. But yeah, it's a broad array of things that you can absolutely find really good work for and high-paying good work for if you're good at it. So, Christian Sparks, anything that you'd like to leave us off with here before we peace out?
I'd echo the sentiment that if you have that interest or that curiosity, that we need tech artists desperately in our field. There's if you have any interest in some of the more environment side of tech art stuff, I think there's the blog post that Len mentioned will have some additional bits that I didn't really have time to talk about today, but I think are pretty interesting. And yeah, definitely dig in if you can. Reach out to people in the community that you see are doing tech art stuff and are like public facing, myself included. If you want to hit me up, I can try and answer some questions. I try to share as much as I can learning stuff because Len's right, it's not really a particularly like well documented area to be in, but it's like super fulfilling, and more people should get into it.
You get to be the person that everybody looks to help solve problems, and if you like that, then hey, that's the role for you.
I think even Wolf created a wizard emoticon for Slack for tech art. Shout out to Wolf on that one.
There is a lot of wizardry. It's true. I mean, there's a lot of wizardry in general when it comes to games development, but I think for tech art, there's some pretty wild things that are sometimes mind bending. That I'm like, oh wow, okay, that's not something we could do. But all of it is magical in games dev. So that being said, thanks for everybody that hung out with us today for this hour. Thanks for Len and Christian for lending some of your time here and being able to talk through your discipline and kind of what we're doing on the project on the tech art front. And we'll be back with another Heart to Heart sometime next month, and we'll make an announcement on that as such. So until that time, we'll see you all later.